Okay, the last lesson in this unit, guys, is going to be to learn how to actually solve these equations. So you're going to learn how to solve for a variable in an equation that involves all fractions. That is completely rational. So, up here, if you guys look up here in this corner, there's actually two ways you guys can solve a rational equation. One way is to cross multiply. Now, it's important that you guys pay attention to this because you can only cross multiply when you have one fraction on each side of your equation. So like for number 1, we have one fraction on each side. We have 3 over x plus 1 on the left and 9 over 4x plus 5 on the right. But if you look at your other problems, like number 2, we have two fractions on the left. We have 5 over x plus 7 over 4. So in that instance, we would have to actually multiply the entire equation by the LCM. So I'm going to do one where it's cross multiplication, and then one where it is not, well, cross multiplication, where you guys have to find that common multiple or that common denominator, which you guys are very used to, hopefully, by now. So let's go ahead and look at number 1 first. So, since it has just a single fraction on each side, we can go ahead and cross multiply here. So we can say x plus 1 times 9 and 3 times 4x plus 5 equal each other. It's like a ratio. So the numerator of the first fraction times the denominator of the second, and the denominator of the first times the numerator of the second fraction. So then all you guys have to do is distribute 3 and your 9. So 3 times 4x is 12x, and 3 times 5 is 15 equals 9x plus 9. And then you guys just solve it. So get all your x's to one side. So I'm going to go ahead and subtract 9x and get 3x plus 15 equals 9. Subtract 15 and you get 3x equals 9 minus 15 is negative 6, and you guys know the last step is to divide by 3. So x equals negative 2. And of course you guys can always go and substitute that back in and check to make sure that x equals negative 2 does actually work. And that's what it means when it says check for extraneous solutions. Always just go back and make sure, guys. Now that's really only going to happen if you have a quadratic equation where you have an x squared that you may not have a solution, or you may have a solution that doesn't work. But you always still need to check. So go plug in x equals negative 2. Make sure that you get the same thing for each side of the equation. So let's go ahead now and look at number 4. So here, guys, if you take a look at number 4, you'll notice that you have more than one fraction on the right-hand side. We have two fractions on the right-hand side, so we cannot just simply cross multiply here. What we're going to need to do is find the lowest common denominator, or lowest common multiple, of our 3 denominators. So again, we'll have to factor it and see what these denominators consist of so that we can find what our new common multiple, or LCM, has to be. So x minus 3 is fine, x plus 3 is fine, but we can factor x squared minus 9 into x plus 3 and x minus 3. So we just rewrote x squared minus 9 as x plus 3 and x minus 3. So it looks to me, looking across here at our three denominators, that we're going to need to include x plus 3 and x minus 3. So again, I'm just going to write that. So our LCM has to be x minus 3 and x plus 3. So you guys are used to multiplying by what's missing in the denominator, and we still have a denominator left. We still have a fraction left. Well, the concept of multiplying the entire equation by that LCM is that when we do that, we should not have any denominators left. It should look like a normal equation with no fractions left. So we have to figure out what part, we still have to figure out what part of the LCM we need to multiply each part of our equation by. So we're going to multiply this entire equation by x plus 3 and x minus 3, technically over 1. So if we're looking at our first fraction, we have 6 over x minus 3. The x minus 3 over here cancels out with the x minus 3 in the denominator of our first fraction. So the only thing we have to multiply that 6 by is the x plus 3 part. Bring down your equal sign. Okay, your 8x squared, it's over top of the x plus 3 and the x minus 3. So they're going to cancel out with both, again, of the things we're multiplying by, our LCM. So that cancels, and you're left with just 8x squared. It does not need to be multiplied by anything. The denominators cancel, and you're left with just 8x squared. Then subtract. 4x is just over x plus 3. So the x plus 3 in its denominator will cancel with the x plus 3 in the LCM. And we're going to have to multiply that 4x by the x minus 3 part. So now we have a normal equation. It's just that it's an x squared equation, so it's quadratic. So again, guys, a quadratic equation means you're going to have two solutions, and you're going to have to set your equation equal to 0 in order to solve. So we have to move everything over to the side with the x squared. So let's multiply and distribute everything through, and then move everything to the right-hand side. So multiply that 6 in there. So 6x plus 18 equals 8x squared minus 4x squared plus 12x. Okay, so now we're going to have to just move everything over to the right-hand side. So now I'm going to move my 6x and my 18. So subtract 6x and subtract 18. There's nothing to subtract the 18 from, so it's just going to get tacked on at the end. So we're going to end up with 0 equals 8x squared minus, 8x squared minus 4x squared is going to give us 4x squared. And then 12x minus 6x is going to give us 6x, and then that minus 18. Now you guys are more than welcome to take it from here and try to factor it and use the quadratic formula. But if you guys look at this, if you see a 4, a 6, and an 18, they're all even, guys. So you can pull out a 2. And that's what I would do, because then it makes your equation a little simpler and makes your life a little easier. So I'm going to pull out a 2 and end up with 2x squared plus 3x minus 18. Or not minus 18, minus 9. So now we need to factor this. So I know that I'm going to need a 2x and an x and factors of 9. So 9 and 1 would work, but that's probably not going to get us anywhere close to 3. So I'm going to use 3 and 3. So if I use 3 and 3, we have 3x and 6x. So if we need to have positive 6 and negative 3, then we need plus and minus. Again, you guys are more than welcome to use your diamond and rectangle. I just prefer the guess and check method and the foiling to check it. So our zero property says that now that we've factored it, we can set each of those factors equal to 0. So let's do that now. So 0 equals 2. 0 equals 2x minus 3. And 0 equals x plus 3. So that would mean 0 equals 2. That's a false statement, guys. So that doesn't even count. Can't include that. But 0 equals 2x minus 3. We can add 3 and divide by 2. So x equals 3 halves in that case. And over here, x would be negative 3. Now, you guys have to check for those extraneous solutions. So, if you guys check this, you do need to check and make sure that it makes it true. But the more important thing, guys, is that you're checking to make sure that you can't divide by a denominator of 0. So, if you go up, I know I scribbled it out, but if you go up and look here, if you have negative 3 as your x value, when you plug that in here, or I'm sorry, when you plug that in here, like I said, scribbled it out, it's hard to see. But negative 3 plus 3 would give you 0. So in this case, you can't have x equals negative 3 because it would make your denominator 0. And you can't have a denominator that's 0 because you can't divide by 0. So in this case, your only solution would be x equals 3 halves. Okay, last example. So number 5. It says from 1995 through 2003, so that's going to be 8 years. That's where the 0 or t is in between 0 and 8. It has to be in between 0 and 8 years, your time. That's the time that we were given to be able to find. But it says from 1995 through 2003, the annual sales S. So sales, S is going to be your sale value of entertainment software can be modeled by this certain equation where T is the number of years since 1995. For which year were the total sales of entertainment software about 5.3 billion. So it's giving us the sales. So your S is going to be 5.3 equals your 848 t squared plus 3220 over that 115 t squared plus 1000. So we're plugging in 5.3 for our S. So how do we like to get rid of fractions, guys? We like to multiply by the denominator. So in this case, there's some big numbers there. But our denominator is 115t squared plus 1,000. So that's what we have to multiply both sides by. So we're going to multiply the entire equation, both sides, by that denominator. So 115t squared plus 1,000 over 1, and then this whole side. Times 115t squared plus 1,000 over 1. What you do to one side, you have to do the other. So that will cancel each other out. And over here on the right, we're going to distribute that 5.3 times both of those values. So 5.3 times 115 looks like it's going to be 609.5. Keep your t squared. And then plus 5,300 equals, now you're just left with your denominator. Or your numerator. So now, since there's no t, guys, there's just a t squared. We're just going to move our t squareds over to one side and our non-t squareds to the other side. So, if I go ahead and do 5,300 minus 3,220. And I'm going to do subtract 609.5 t squared minus 609.5 t squared. So these cancel and these cancel. And you're left with 2,080 equals 238 t squared. So how do we, I'm getting ahead of myself. We actually want to divide both sides by 238 first. Come on, missus. So 2080 divided by 238 gives us around 8.74 equals your t squared. So now, how do we undo a t squared? How do we undo anything that is squared? We have to take the square root. So t is going to be equal to around 2.94. So I'm going to round that up to about 3 years. So when it asks for which year were the total sales of entertainment software about 5.3 billion, 3 years after 1995. So if t is equal to 3 years, then it's going to be the year 1998, 3 years after 1995. So go ahead, try the last two on this page, guys, and then try out the check for understanding.